Dear students, today we are going to study Fajan's rule. Okay, so already we have seen what is covalent bond, polar covalent bond, ionic bond, everything. So when you see, when a compound is covalent bond is formed. When ionic bond is formed. So what is actually, when a covalent bond is formed, no bond, if covalent, it is not 100% covalent. There will be some sort of ionic character. So when you take ionic bond, there will be some percentage of covalent character. Okay, so this character can be explained in terms of Fajan's. So it is called Fajan's rule. So first let us see. When we take the compound, so positive, so cations, C cation, and here anion. Okay, so cation, this is cation, plus this is anion, here minus. So this is two oppositely charged ions. When they come close to each other, what is happening? Which one? What is happening here? The cation polarizes the anion. The cation polarizes the anion. That means what happened? This one, when it comes closer to each other, no? This anion shape, normally atoms or ions we assume to be a sphere, spherical shape, right? So this cation, it pulls the electron cloud of the anion towards itself. So how it is coming? Like egg shape. So as a result, the electron clouds are pulled towards the nucleus. So the electron cloud is between positive and negative ion. So it is called distorted. So the cation tries to distort the electron cloud of the anion. So this property is called polarizing power. Okay, what is polarizing power? The tendency of cation to distort the electron cloud of the anion towards itself. That is called polarizing power. The next one, the anion gets distorted. Okay, anion, the shape is spherical. When it approaches near when cation approaches the anion, what is happening? Which one? The anion gets distorted. So this property is called polarizability. Okay, so first one we can see the power of the cation. Number one, the power of the cation. Power of the cation to distort the electron cloud of the anion. Electron cloud of the anion. Cloud of the anion is called polarizing power. Polarizing power. Okay, so if the size of the cation is small, suppose we are taking NaCl and lithium chloride. So lithium has smaller size. So lithium has greater tendency to polarize the anion than KCl, than K plus. Is it clear? So size of the cation is small, the polarizing power will be more. Is it clear? The next one, second one is polarizability. The tendency of the anion to get distorted is called polarizability. The ability of anion, the ability of anion to undergo distortion. Distortion is called polarizability. Polarizability. Okay, here larger the size of the anion, polarizability will be greater. Suppose for example, if you take lithium fluoride and if you take lithium chloride, you see here fluorine smaller, chlorine larger. So fluorine ion is smaller here, chlorine ion is still larger than this one. So when it is larger, what happened this one? The valence electron, the electron cloud is little away from the nucleus. So the distortion is little more easier than the smaller size of anion. So size of the anion increases, the polarizability increases. Is it clear? Okay. So next one, we can see what is Fajan's rule. So first we must know what is polarizing power and what is polarizability. The cation has the polarizing power and anion, how it get distorted, that is called polarizing power. Is it clear? Next one, the extent of covalent character can be explained in terms of Fajan's rule. Okay, so first Fajan's rule, smaller the cation, greater the polarizability. Larger the anion, greater will be the polarizing power. So first one we can write here Fajan's rule. In Fajan's rule, the first point is smaller the size of cation. Fajan's rule. Fajan's rule. Number one, smaller the size of cation. Smaller the size of the cation. Size of the cation, greater is the polarizability, greater is the polarizing power, is the polarizing power, polarizing power. Example, lithium chloride, then what you can do is sodium chloride. So here which one? This is plus, this is minus. So this is plus, this is minus. So lithium plus has greater polarizing power than Na plus. So clear? That's the first point. Second one, what you get, smaller the size of, next one, larger the size of anion, higher will be the polarizing power. So second one is larger the size of anion, higher will be the polarizability. Polarizability means ability. Already we have discussed polarizability is the tendency of the anion to get distorted. So that is called polarizability. For example, lithium, what we can write one, lithium fluoride, sodium chloride. Here you see fluorine smaller, chlorine bigger. So here lithium chloride will have, this will have more covalent character than sodium chloride. Then lithium fluoride and sodium chloride, the anion size is large. Anion is large. Here anion is less, small. So where larger the size of the anion, the covalent character increases. So sodium chloride has greater covalent character than lithium fluoride. Is it clear? Okay. Then when we are taking, third point is when we are taking the ions of similar size, the ions which have pseudo inert gas configuration has more polarizing power than the gas which has inert gas configuration. Is it clear? So first one, third point we can write which one? When the ions, when two compounds, the ions which has pseudo inert gas configuration, that will have more polarizing power than the ion which has inert gas configuration. So what you can write for when you compare for two cations, of similar size. Example, copper chloride and NaCl. Copper chloride and NaCl. So when you take this one copper chloride, for two cations are similar size. So here you see this plus, this minus, this plus, this minus. So the ions which have, has NS2, NP6, ND10 electronic configuration has more polarizing power than, so NS2, NP6, ND10, that we can call which one? Pseudo inert gas configuration. Inert gas configuration. Has more polarizing power than the ion with NS2, NP6 configuration. Okay, that means this is inert gas configuration. Okay, so first one we can understand, we can feel, we can see, find out how it is. So this is NS2, copper plus. So copper, how will you write the electronic configuration? 4s2, 3d10. Okay, 4s1, 3d10, then 4p. Copper, when you write this one, copper atomic number of copper is 29. So how will you write one? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then what will come? 4s2, 3d10, 4s1, 3d10. Okay, see here, for the cations of similar size, that means when size of cation is similar, okay, so the ions which have NS2, NP6, ND10, that means pseudo inert gas configuration, has more polarizing power than the ion with NS2, NP6 configuration. Okay, so first one, if you see sodium, copper 29. So this is copper electronic configuration. Copper plus what comes? This one electron goes. So we will get 3d10. But when one electron goes here, it doesn't attain inert gas configuration. Only P is filled up, S is filled up, then 3D. This 4 is 0. Okay, this is pseudo inert gas configuration. Stable configuration, but not inert gas. But in case of sodium, if you take Na plus, so sodium, how will you write which one? Na, sodium 1s2, 2s2, 2p6, 3s1. The next one, Na plus, this will go off. So 1s2, 2s2, 2p6. So this is 10. This is inert gas configuration, helium, neon. Neon is actually, it attains the inert gas configuration of neon. So this is inert gas configuration. Okay, this is not inert gas configuration when it attains Cu plus. Okay, so these are actually 3 points in Fajan's rule. So first one is smaller the size of the cation, more will be the polarizing power. Okay, second one is larger the size of the anion, more will be the greater will be the polarizability. Then third point is when two cations of similar size, how we'll understand that one? The ions which has pseudo inert gas configuration, that means it's not originally inert, that doesn't attain inert gas configuration. It shows pseudo inert gas configuration, appears to be inert gas configuration, but actually it is not inert gas configuration. 29, if so one electron goes, you get only 28. That is not inert gas configuration. So that cations will be having more polarizing power than the ions which shows inert gas configuration. Okay, so now we can understand when the molecule, for example, this is a very important point, we can understand this one, lithium chloride, lithium chloride. Okay, very important point, lithium chloride. Then sodium chloride, lithium, sodium, potassium, lithium, sodium, potassium, rubidium and cesium chloride. Okay, so when you move from here left to right, what happened? This one we have studied, smaller the cation, more will be the polarizing power. So covalent character decreases. Covalent character decreases. Covalent character decreases. Okay, here you see this is common, Cl, here this is common. So size of cation increases. Actually, size of the cation should be smaller than covalent character more. So this will have highest covalent character. Next one is, if you take lithium fluoride, then lithium chloride, fluorine, chlorine, bromine, then iodine. Okay, so larger the ion, here this is the common one, this is common, this is common, lithium chloride, this is common here. So the anionic size increases. So what is happening when anionic size increases? The covalent character increases. Covalent character increases. Okay, so what we can understand from here, we can write covalent character. Covalent character is directly proportional to anionic size. The next one is very important point. Then covalent character is inversely proportional to cationic size. Okay, these points are very important. Okay, you will study this one in S block also, but in Fajan's rule this is very important. Okay, thank you children.